Have you ever gazed upon a star-filled night sky and pondered the vastness of space? The universe is a place of unimaginable scale and mystery, a realm where billions upon billions of stars congregate to form galaxies, and where those galaxies themselves are scattered across an expanse that seems to have no end. As we explore the cosmos, we are confronted with the profound question, where does it all end? The concept of an end to the universe is one that has puzzled astronomers, physicists, and philosophers for centuries. Our intuition tells us that everything must have a boundary, a point where it ceases to exist. However, when it comes to the universe, our intuition may be misleading. The universe, as we understand it, does not conform to our everyday experiences of space and time. Imagine yourself embarking on a journey to the furthest reaches of the cosmos. As you travel through space, you would encounter countless galaxies, each a dazzling island of stars, gas, and dust. Yet, no matter how far you venture, you would never reach a point where the universe simply stops. Our ability to observe the universe is limited by a fundamental constraint: the speed of light. Light, despite traveling at the fastest speed possible, takes time to traverse the vast distances of space. When we look at a distant star, we are not seeing it as it is in the present moment, but as it was when the light we are observing first left its surface. This means that the farther away an object is from us, the further back in time we are seeing it. The most distant objects we can observe are those whose light has taken the entirety of the universe's history to reach us. This creates a boundary known as the cosmic horizon, or the observable universe. The observable universe is not a fixed boundary in space. Rather, it is a constantly expanding sphere centered on the observer. As time passes, light from more distant regions of the universe has time to reach us, expanding the horizon of what we can see. To understand the nature of the universe's expansion, we must journey back to the very beginning of time, to an event known as the Big Bang. According to the prevailing scientific theory, the universe began as an incredibly hot, dense state some 13.8 billion years ago. In a fraction of a second, the universe underwent a period of rapid expansion, inflating from a size smaller than an atom to a cosmic scale. The evidence for the Big Bang and the subsequent expansion of the universe comes from a variety of observations, including the redshift of light from distant galaxies. Redshift is a phenomenon similar to the Doppler effect for sound waves, where the pitch of a siren changes as it moves towards or away from us. Just as the pitch of a receding siren is lower, the light from distant galaxies is stretched towards the red end of the electromagnetic spectrum. This redshift indicates that these galaxies are moving away from us, and the greater the redshift, the faster they are receding. The expansion of the universe is not simply the movement of galaxies through space, rather it is the stretching of space itself. Imagine the universe as a giant sheet of rubber with galaxies scattered across its surface. As the sheet is stretched, the distances between the galaxies increase, even though the galaxies themselves are not moving across the sheet. This concept of an expanding space-time fabric has profound implications for our understanding of the universe. It means that the universe does not have a center or an edge in the traditional sense. Every point in the universe is moving away from every other point, and there is no preferred location. The expansion of the universe also helps to explain why the cosmic microwave background radiation, a faint afterglow of the Big Bang, is observed to be coming from all directions in the sky. This radiation, which permeates all of space, was emitted when the universe was much hotter and denser, and it has been stretched and cooled as the universe has expanded. Section 5. Beyond the horizon. What lies beyond our sight? While the observable universe represents the limit of what we can currently see, it is important to remember that the universe itself is likely much larger. The cosmic horizon is not a physical boundary, but simply the point beyond which light has not had enough time to reach us since the Big Bang. It is entirely possible that there are vast regions of the universe beyond our observable horizon, filled with galaxies, stars, and planets that we may never be able to observe directly. These regions would be subject to the same physical laws as our own observable universe. but their properties and evolution could be vastly different. The concept of a universe that extends far beyond what we can see is both humbling and awe-inspiring. It suggests that our place in the cosmos is even more insignificant than we might have imagined, yet it also opens up the possibility of endless discovery and wonder. Section 6. The shape of the universe, finite or infinite? The question of whether the universe is finite or infinite is one of the most fundamental and challenging questions in cosmology. The shape of the universe is intimately connected to its fate and its ultimate destiny. One possibility is that the universe is finite but unbounded, similar to the surface of a sphere. Just as one can travel around the surface of a sphere indefinitely without ever reaching an edge, so too could one potentially travel through a finite but unbounded universe forever. Another possibility is that the universe is infinite and extends forever in all directions. This would mean that there are infinitely many galaxies, stars, and planets, and that the universe has no center or edge in any meaningful sense. Section 7. The illusion of an edge, navigating a boundless expanse. The human mind is accustomed to thinking about space and time in finite terms. We experience the world around us as having boundaries and limits, and it can be difficult to grasp the concept of a universe that is truly boundless. However, it is important to remember that our everyday experience of space and time is not necessarily an accurate reflection of the true nature of reality. The universe, as revealed by modern physics, is a strange and wonderful place where the rules of classical physics break down and where the very fabric of space-time can be warped and distorted. The concept of an end to the universe is ultimately an illusion, a product of our limited human perspective. The universe, as we currently understand it, is a boundless expanse that defies our attempts to define its limits. Section 8. Unraveling the Mysteries, Dark Matter, Dark Energy, and the Fate of the Universe. As we continue to explore the cosmos, we are confronted with new mysteries that challenge our understanding of the universe. One of the most perplexing discoveries in recent decades has been the realization that the vast majority of the universe's mass and energy is not in the form of ordinary matter or radiation, but rather in the form of invisible and enigmatic substances known as dark matter and dark energy. Dark matter, as its name suggests, does not interact with light or other electromagnetic radiation, making it invisible to telescopes. However, its presence can be inferred from its gravitational effects on visible matter such as stars and galaxies. Dark energy, on the other hand, is a mysterious force that is causing the expansion of the universe to accelerate. The nature of dark energy is one of the biggest unsolved mysteries in modern physics, and its discovery has revolutionized our understanding of the universe's fate. Section 9. An everlasting quest, exploring the cosmos and our place within it. The quest to understand the universe and our place within it is one of the oldest and most enduring human endeavors. From the earliest stargazers to the most sophisticated modern telescopes, we have always been driven by a deep-seated curiosity about the cosmos and our connection to the grand scheme of things. While we have made remarkable progress in understanding the universe, there are still many mysteries that remain. The nature of dark matter and dark energy, the shape and size of the universe, and the ultimate fate of the cosmos are just a few of the questions that continue to intrigue and inspire us. The journey to unravel the mysteries of the universe is a journey that will likely continue for generations to come. As we explore the cosmos, we are not only expanding our knowledge of the physical world, but we are also gaining a deeper appreciation for the beauty, wonder, and sheer immensity of the universe we inhabit.